So with SDN, or software-defined networking, there's quite a variety of different definitions floating around. Here they talk about the abstraction of the network infrastructure. I think that's one good way to look at it. You can think about it as virtualization of the network, a way for us to be able to leverage those APIs or programmable interfaces to be able to manage and provision and control our network. I think another good way to think about SDN is that separation of control plane and data plane. We'll look at a couple different topologies. There's the total separation where you have just the control plane and then data plane physically on the devices. And then there's also a hybrid. So we'll take a peek at some of those topologies here in a moment. There are some misconceptions too with SDN. A couple things to think of in regards to what SDN is not. It's not intended to just make everything easy. It's certainly not super narrowly defined. We'll see that. It's been evolving. It's been changing. When we look at what SDN was like 4 or 5 years ago versus what it is today, it's changed, and I think it will continue to change. It wasn't designed to replace network engineers. It was designed to make our lives a little bit easier and more efficient. It's not going to mandate us to become programmers, but we should begin to learn some programming if we don't already. And then here are some of those concepts of the traditional versus the SDN. So when we talked about control and data plane a little bit earlier, we know that each of those things generally reside on every single physical device. Now, sure, if you look at something like a chassis-based switch where your controllers, right, are your control plane, and then maybe your line cards are the data plane. This you can kind of sort of think about as far as, what SDN is moving towards. But, we might only have a maximum of 8 or 10 or whatever number of line cards, right? Where generally with a big classic SDN, you can have one control plane and hundreds of nodes instead of just a handful. So each of your nodes, right, are going to have their own unique data plane. So there should be just the little orange, right, listed here, and no control plane. All right, so the control plane just resides in one centralized location. Now, sure, is there HA or 2 or 3 controllers deployed? Definitely. But essentially, this is what the classic SDN topology looks like. Now, generally, when we look at hybrid, this is having the ability to support control plane and data plane locally on every physical device and the controller as well. So the nice thing about this is that we're doing all of our provisioning at the controller, but if we do need to drill down and go into one physical device, maybe it lost communication with the controller or whatever the case may be, we can always still communicate with the physical device through the control plane directly on it. And this is actually what Cisco's been doing with their ACI. All right, so we'll look at some examples of ACI here in a moment. So why change? Why do we want to move to SDN? Well, sure, we're still already familiar with command lines. It's just going to have a little bit of a different approach, and there are going to be lots of different ways that we can configure our devices. So sometimes we might want to either pick a method that we like best, or sometimes there's a particular method that our organization likes to use. There's certainly an increased need for those APIs, and there's generally going to be some sort of centralized controller. Some other terms we might need to know are those northbound APIs. A lot of times that's going to be happening between the applications and the controllers. So sometimes things like REST APIs might happen between the applications and the controller. Now, downstream or southbound of us, if we are logged into the controller, are going to be the APIs that actually communicate with the physical hardware, right? So these can either be APIs specific to an organization like Cisco, or they can be commonly used APIs like RESTconf or NetConf and things of that nature. All right, so we also have, just a little bit of a list of some different types of open source software that's currently out there. They go into a little bit of detail on some of this in the courseware, but not a lot. Generally, when we look at OpenFlow, that's happening between controllers and switches. We can also have Open vSwitches. We'll look at FDIO. Generally, that is several projects and libraries to be able to use on generic hardware. And this vector packet processing, they say, was actually a technology that was donated by Cisco. We also have a couple different programmable interfaces. So on-box examples are things like Tickle or EEM, Python. Some of you guys may have already been using some of these in the past. And then things that are off-box or scripts that work outside of the device are things like, those REST APIs and NetConf and RESTconf. So, we can see some examples of those here. And then before we wrap up this section, they touch on this acronym of COMS under the DevOps umbrella. And I guess you can say that this is somewhat of a methodology or a framework that allows our engineers to be able to pick one problem out at a time and take it on. So we're trying to do these small incremental steps for our framework. All right, so sometimes you'll read about this. I hadn't really heard much about it, but culture, automation, lean, measurement, sharing. I'm also not one of those people that is well versed in things such as agile methodologies and project management. So this might just be something new to me personally. But I can see the benefits to it, increasing deployment, faster time to market. So I'm sure this is something geared more towards those DevOps teams. Now, if you guys weren't already familiar with where some things kind of fit into play, maybe you've heard of Ansible and Puppet and Chef, and maybe you knew that they were configuration management tools, but maybe you didn't know Ansible was geared more towards Debian and Chef more towards Red Hat and Puppet more towards Ubuntu. And then if we needed to look at different versions, we could go to places like GitHub, different programming languages, Ruby and Python. So with regards to Cisco's ACI, this is essentially Cisco's implementation of SDN. So what's cool about this is generally this is deployed in the data center. It is supported on the Nexus hardware, and it is mutually exclusive from running your Nexus hardware in NXOS mode. We will see some other examples of ways that Cisco is deploying SDN. But just really quick, the controller is going to be your APIC. That's generally hosted on a few different VMs, which is your central point of management. But generally, you can always have that APIC or have the control plane on your physical hardware as well. So it is that concept of a hybrid control plane data plane. Also notice the topology is a leaf and spine topology. So we might start off with 2 or 4 spine switches up at the top here. And then we can have lots of different leaf switches. And what this allows us to do is scale horizontally very easily. And no matter where all of our VMs reside, we are only going to be 1-2 hops away. So that's kind of the nice thing about ACI. Obviously going to simplify the deployment lifecycle. It's going to have an open ecosystem approach for physical and virtual environments, and supports lots of open APIs. So obviously we see some other benefits to it down here as well. Here is some other examples too of some of the APIs and the programming that we might use. So REST or HTTPS, anything northbound of that controller, southbound of that controller, netconf, restconf, OpenFlow, OpFlex, and then of course we have our traditional CLI and SNMP that falls under that southbound category as well. Lots of different use cases for this. Essentially, we can see our data traffic that is traversing a physical link or physical interface. And then we also have where our restconf and netconf resides. So between our servers and our different physical devices. And then you can see where the CLI is supported as well. So we have some limitations potentially on where our CLI resides. Some other implementations of SDN or some other solutions. We have SD Access, our Cisco DNA. We have SD-WAN, and we have SD Branch. So all of these are going to be geared towards all of your different types of physical topologies.